the design process of a typical bottle. The design process can be broken into distinct steps. Concept design. The geometry, which can possibly be parameterized, can be easily imported. The geometry will be manipulated for the subsequent analyses, each having its own requirements. But the starting point for all the analyses will be the same. Material, thickness distribution, prediction, and optimization. Considering the manufacturing process, in this case extrusion blow molding, predicting what the thickness distribution of the bottle will be, and possibly fine-tuning what it is and optimizing it even. Filling simulation. Using high fidelity CFD, different filling processes may be easily simulated, representing different materials, fill rates, fill nozzles, etc. Liquid dispensing. This is a two-way fluid structure interaction, FSI for short, that considers the bottle wall's structural behavior as well as the liquid presence within the bottle during the dispensing process. The thickness variation of the bottle is taken from the manufacturing process simulation. Drop test. Again, considering the thickness variation from the manufacturing process, the drop test behavior of the bottle is examined. The liquid presence within the bottle is also considered. The extrusion blow molding process is simulated. Two different settings are shown. A baseline setting on the left-hand side and an optimized setting where the initial thickness of the preform is adjusted as to meet predefined final thickness variation. This allows for a smarter bottle where the thickness where needed is adjusted and thin where not really required. We are looking at the final thickness variation comparison between the baseline design and the optimized design. It is worth noting here that while the final weight of the optimized design is higher, the minimum thickness of the bottle of the optimized design has increased substantially more than the net increase in the overall bottle weight. The weakest spot, the bottle corner, has been simply eliminated. Bottle shapes are typically complex and may contain features that are relevant to the bottle use and maybe even its structural behavior. Automatic mesh adaptation offers an efficient way to capture these features. The next step will be looking at the fill process of the bottle. The fill pattern is certainly affected by the liquid properties. For example, oil is 1,000 times more viscous than water, and it can be clearly seen how that affects the fill pattern. Typically, it is desirable to decrease the cycle time to increase the productivity. But at the same time, the fill needs to be complete, and the level of turbulence needs also to be monitored during the fill process. Finally, the amount of gas trapped during the fill may also be important and could affect customer perception decision during the buying process. The next step is now looking at the dispensing behavior of the bottle during its use. The dispensing process is truly multi-physics. During the squeezing of the bottle, the consumer has to overcome certain resistance by the bottle itself, as well as the liquid resistance within the bottle. Moreover, the thickness variation of the bottle due to the blow molding process also affects the structural behavior. Simulation also provides powerful visualization and quantitative prediction of the dispensing rate with time. This is also important to ensure positive user experience. Last but not least, we we'll be looking at the drop test of the partially filled bottle. The drop test behavior of the bottle is affected by the liquid level inside the bottle, its material, its thickness distribution, which can easily be mapped from the blow molding process simulated earlier. Also, typically, the maximum deformation and stresses are of interest. Under this drop test configuration, optimizing the bottle thickness and increasing the minimum value of that thickness proved to be crucial in reaching a design that passed the drop test requirement. As a summary, we have looked at the entire simulation-driven product development process of a typical consumer product bottle, from manufacturing to the filling process, its use during a dispensing of a liquid, and finally its drop test behavior.